in this tutorial, we'll start looking at how to come up with the derived SI units. For us to understand this, we need to remember the 7 SI units, but in this case we'll focus on now we're going to focus on length. We know length is a physical quantity and its SI unit is meters. It's meters. The symbol is m. And time, we know the SI units for time is seconds, and the symbol is S. And we have temperature. We know the SI units for temperature, it is Kelvin. So and so on, but in our study we'll just use these to help us come up with the derived SI units that are here, because look at the example. You're saying derive the SI units for density, force, then we have speed and momentum. So now let's do this step by step. So to do that, we need first of all to know the formula for calculating density. We know that density is given by mass over volume. Now we know the SI units. The SI units for mass, is kilogram. And we know the symbol is what? Kg. So now when we come here, we know that the SI unit for mass is kg, so I'm writing the SI units for mass kg. Then we know that volume is given by this formula, L times L times L. So now we know that the SI units for length, it is meter. Then there is another meter, so again we are multiplying meter and another meter. So meter multiplied by meter, it will give us cubic meter. So now since this is volume, so we'll get the cubic meter, this cubic meter, and bring it here. So it means it will be cubic meter. So therefore the SI units, the SI units for density in words will be kilogram. Remember, every time you see this dividing bar line, it means per. Then this one will be cubic meter. So these are the units for density. So now let's move on. We look at the next one. In our example here, the next one is force. We know that force, the unit for force is F is equal to MA. Again, we know the SI units for force, it is in kilogram. But what about the SI units for acceleration? Acceleration is given by velocity, final velocity minus initial velocity divided by time, which we know that the SI unit for velocity is meters per second over the SI units for time is second. This means that I have m over second, then times 1 over second. So when I multiply the two, what am I getting? I'm getting m over second squared. Then this means we have m slash second squared. Now taking this and bringing it here, what are we going to have? It means we are going to have dots m per second squared. So therefore the SI unit for force is kilogram meter per square per squared second, which is also known as Newton, and its symbol is capital N. Now what about speed? Now let's look at speed. That will be our C. So speed, we know speed is equal to distance divided by time. So the distance is the same as the length, so it means it is meter, then over, what is the SI unit for time? We know it is second. Again, we know this line means per. It means that therefore speed's SI units are meters per second. Now what about momentum? So that will be D. Momentum is P is equal to mass multiplied by velocity. So now what are the SI units for mass? It's kilogram. Then we are multiplying with the velocity, which we have already found to be meters per second. So therefore the SI units for momentum is kilogram meter per second. So see you in the next video, where we're going to talk about the conventions from one unit to the other. Stay tuned.